Ozone is a molecule comprised of 3 oxygen molecules, and it is found in the stratosphere, a layer of the atmosphere about 6 to 10 miles above Earth's surface. It acts as a defensive shield, absorbing UVB radiation. While there are only about 3 molecules of ozone per 10 million air molecules in the atmosphere, all life on the planet depends on its presence. Without ozone, the amount of radiation reaching the Earth would create uninhabitable conditions due to high temperatures and excess amounts of radiation. However, there has been an increase in the depletion of ozone over the past century. There are several believed reasons for this decrease. One cause is the presence of chlorofluorocarbons, also known as CFCs. CFCs are a family of chemical compounds developed from man-made products such as refrigerators and spray can propellants that increase the depletion of the ozone by a process called the Chapman cycle. This is the natural cycle by which ozone is created and depleted. It's a cycle that uses light to break down diatomic oxygen to form ozone, then uses halogens such as chlorine and fluorine to break ozone back down into diatomic oxygen in a process called oxygenation. Due to the higher concentrations of halogens caused by CFCs, more and more ozone is being used to create diatomic oxygen, creating and widening gaps in the ozone. An additional cause for the depletion is volcanic activity. Volcanic activity increases sulfur concentration in the form of sulfuric acid, which acts as a surface to release chlorine from CFCs. In essence, sulfuric acid is what makes CFCs so bad for the ozone layer, acting as something like a catalyst, enabling the benign chlorine to change into a much more active form. Mass unregulated production of man-made halocarbons such as chlorine and bromine, along with sulfuric injections from volcanoes, increases surface areas of aerosol particles, directly influencing the polar stratosphere and creating gaps in the ozone. These gaps prevent the ozone from blocking highly radioactive UVB rays from the sun, spelling out disastrous outcomes on Earth from an ecological standpoint. Radiation would permeate plants and animals, damaging DNA, causing a meteoric rise in cancer, and halting the process of photosynthesis, eventually leading to worldwide extinction. By averaging total ozone column measurements from solar backscatter satellites and analyzing data from the total ozone mapping spectrometer, scientists were able to observe and record the changes in ozone density and area in the Arctic and Antarctic regions over a decade. Scientists used 3 different tests to determine the cause behind changes to the polar ozone since 2000. First, they performed simulations observing time-variant temperature and winds in the regions. They then followed volcanic emissions of sulfur from numerous blasts. Finally, they conducted a simulation to focus on annual changes of meteorological factors such as weather shifts. They found that areas with higher concentrations of chlorine, bromine, and sulfur typically had higher seasonal growth of the ozone hole. However, overall reasons for the marginal annual replenishment of the ozone did not show a clear connection to temperature dynamics. The Montreal Protocol is an international treaty credited for reducing emissions and limiting ozone depletion. The agreement eliminated man-made products which are responsible for stratospheric ozone destruction. By eliminating these aerosols from the air, it has steadily decreased the rate at which ozone is depleted. After 30 years, part of the ozone have finally showed signs of reemergence in the Arctic region. There is a 3-step process in the reversal of ozone depletion. If we graph ozone depletion against time, we see that the ozone has been damaged at increasing rates, in part due to human activity. But this is changing. The first step entails a deceleration of the rate of depletion, which you can see here as the increasing slope of the graph begins to straighten out. The second step is a plateau in the rate, indicating a halt in damage. Logically, the next step would be a reversal of the previous pattern and the graph would slope downwards, signifying ozone healing. However, third step has not yet been observed. While it has been proven to an extent, the 3-step process is still unpredictable because of the invariability of ozone recovery. The cause of the invariability is a natural random fluctuation that occurs in Earth's ozone. Volcanic aerosol and fluctuations in chemicals in the air change dramatically, even without human interaction. However, since the Montreal Protocol in the 1990s, documented results from balloon and satellite ozone data combined with volcanic aerosol measurements and chemistry climate models conclude that the ozone is in fact recovering. Excluding the invariables, this standardized information points to a decreasing hole in the North Pole by comparing 15 years of data and comparing the data to theoretical data.